Hi guys, this is a video of explanation of vector addition CUDA code. Let's start. CUDA is built upon the layers of C and C++, so if you are familiar with programming languages, C and C++, you may find many syntax familiar. First, this is including all the headers needed, and then this is CUDA kernel for vector addition. Global, it means it is called from the host, meaning the CPU, and run on the device, meaning the GPU. And this is basically because in CUDA, when a kernel is called, it is assigned upon a block base, and then every thread in the block will run this code. And this is for each thread, it first calculates its index using this formula and do the vector addition if its index number is smaller than the required number. This part, it runs on the host, meaning CPU. It is, me, the very familiar and our old friend. And this is basically declaring the arrays on the host, and this is the device vector printers. And then initialize host input vectors, basically assigning values to the host vectors. Okay. And we all know the computer, it requires the memory, and if we have the memory, we put data inside and we can do the calculation and many other stuff. So first, similarly, we allocate device memory using the previous device printers. And the reason why we declare these device printers, like here, in main, the CPU code, is because the CPU and GPU is connected with each other using a motherboard. So on the hardware level, CPU and GPU is connected, and we can use this NVIDIA PCI and to do the data transfer. We allocate the device memory first. This is the CUDA malloc is very similar to the malloc in C. And here we are casting the printers from, I think, int to void. It's because to generalize it. So this CUDA malloc fits to any data type, float, int, and size. And then we copy data from host to device. We then launch kernel with enough block or threads. First, we declare the threads per block and block per grid, and then we call the kernel. And just for another remind, this is all in the main. In the main, meaning it runs on the CPU host. And when we call this kernel code, the kernel function will start running on the GPU, and the CUDA runtime is assigning many threads. And then we copy the result back to the host. And print result. And we also need to free the device memory. Remember to do that. So yeah, this is a very I would say basic walkthrough of the factor addition CUDA code. I am giving the main ideas here. Alright, thank you guys.